Good morning, class. So today I'm making a quick video on this practice problem that we have for making a tire. And this problem focuses on the use of various Revolve extrudes as well as Revolve cuts. So let's start off by making a new part. So I'm going to File, New, click Part, and then select OK. I want to make sure I'm in the correct unit system. So this unit system for this part is millimeter gram second. So in the Solidworks interface, the easiest way to change that is on the bottom right-hand corner of the screen. We have a little toggle menu here, which we can click, and we can change that to millimeter gram second. That's typically going to be the first thing you want to do when you start a new part for a question like this. The next thing is we want to check and see where the material and the origin are. So here we have the material is natural rubber. That's not one of our favorites. So we're going to go ahead and go to Edit Materials. Now there is rubber listed there, but that's not necessarily the same thing. So what we want to do is we want to open up the rubber category, and then we have here natural rubber, which is going to be maybe slightly different than the rubber listed in the defaults. We can also check and make sure this is the right material by comparing the density. So here we can see we have a density of 960 kilograms per meter cubed, and here we've given it as 960 kilograms per meters cubed. So we know we have the correct material by looking at that as well. So I've got that set. The next thing I'm going to do is I'm going to look at the origin of this component. So inside the view here, I can say, okay, where do I want to put the center of my part? And I can make this a little bit bigger so we can see a little bit better. We want to make sure we understand the geometry of the part before we get too far in making it. So here we have the tire kind of almost in full view. And we can see that it has an outer radius of 1,100 whatever units this is. I guess this is millimeters, right? So that'd be 1.1 meters. It's got a rim diameter of 900, and we probably can see a little bit better if we zoom in on this corner, and the dimension for that rim diameter is going right to the corner on the kind of inside of that outer round, and we have it annotated here as well as to where that wheel rim diameter is supposed to be located. And then we have a section view going from, well, really the section view is here relative to A. And then we have a detailed view in that section view, which shows us what the cross section of the tire really looks like. So the difficulty here is we need to do revolve of this cross section about the middle of the wheel. And to do that, the easiest thing to do is for us to create a sketch on probably the right plane, and then specify the center of the wheel, and then draw all this geometry at some distance from that center. So let's take a look at how that'll work. I'm going to go to a side-by-side view so we can see our Solidworks as well as our quiz prompt at the same time. And if you've got a dual screen display, then obviously that makes this a little bit easier as well. And I'm going to start by going to the right plane. I'm going to sketch on the right plane. I always like to have the first thing that I draw be on the origin to locate the rest of the parts. But in this case, the first thing I'm going to draw is actually going to be the center line for the revolve. So I'm going to draw a center line from the origin kind of horizontally. I don't really care how long that line is. The next thing I'm going to draw is the outline of half of this tire. And I want to do half because I know this thing is symmetric about a vertical center, and I won't have to put as many items on the page if I draw half. And I prefer to do mirrors inside the feature manager because the relations can be difficult to fix if we have kind of symmetry in the sketch. So just as a recommendation, when you're drawing things out, I would recommend that you keep your symmetry and your mirrors in the feature level. So I'm just going to draw the outline of kind of the bottom half of this part. I'm not going to be able to get a tangent. So this is not tangent at the corner here. So I'm actually going to exit that tool. I'm going to come back into it. I'll draw the last portion of this kind of rim section of the tire. And then before I get too far on this, I want to start adding some dimensions on this. So I'm going to say that this distance here from my central axis to this point on the rim, and I want to set the distance of that as a diameter, which I can get by going on the bottom half of the center line as 900. You notice that it doesn't actually scale anything based off of that. Like nothing changed position or size because that was the first dimension I added. And that can be helpful in terms of keeping track of how big things are. Now I'm going to zoom in on this a little bit, and I have some dimensions down here. I'm going to try and work my way up from the bottom. So I've got 20 as the total width of this. So we'll do left to right, specify that as 20. I'm pretty close to that at the start, so that makes things a little easier. If as you're doing this, as things get messed up, just kind of drag them around and get them close to where they should be before you add too many dimensions. The height of this line is going to be 10. I actually skipped over this 10 here. I'm going top to bottom. We have the width between the edge of the part and then kind of this line in the middle of the rim as being 10. Try and get that the same way we have here. Although I could put it on the other side as well, just because 10 or 20 minus 10 is going to be 10. But I want to stay as consistent with the drawing that I'm given as possible, which probably would have made sense if I drew this on the left side instead of the right side, but just didn't think about that at the time. We've got this is 10. We've got a 60-degree angle between a vertical line and this kind of angled line on the edge of the part. So we'll add that in. And again, I'm trying to move these around and keep them somewhere close to where they're given inside the drawing that I have. And then I have a distance from the center of the tire to this line as being 30. So I don't have that center line, so I'm going to add that. And I'll come up above my sketch because I can use that for the center of my circles as well. And I want the distance between this guy and the center to be 30. And I'm trying to put these in the same position or close to the same position as they're given in the drawing. So that way you can see I got 20, 20, 10, 10, 10, 10, 10, 10, 60, 30, that I have all the same dimensions in the same spots. And I don't have really any relations on here. I'm going to save any relations that I want to add to later in the process to make sure I'm not adding relations that I don't want. All right, and I've got two arcs here. I'm just going to use the center point circle, and then I'm going to trim them out later because I like to use that tool. If you want to use a center point arc, that works fine too. So actually, let's do it both ways. We'll start with a circle. So center point circle. I'm going to put the center here and just drag this out to the end like that. And then I'm going to trim away kind of the extra material that I don't need. We'll try the other option using the arc. So this is a center point arc in one of the 3 different types of arcs. I do want this to start below the center of the larger circle. So I'm going to come down a little bit below the center of the larger circle, come over, click the start of the arc, and then the end of the arc. And maybe that's a little bit faster. I'm going to close off this top section so I have a closed cross section, and you see I have this kind of omega shape. And now I've got a closed cross section. I can actually revolve this, but I need to fully define these arcs first. So we'll set the distance between the two of them as 5, so the distance between the two centers specifically. Again, still trying to put these dimensions in the same spot. The radius is 40. If you're doing this as a circle before you're adding the dimension, make sure you're converting that. And a radius of 54.5. Okay, so I'm fully defined. I've got the same dimensions as are given in the sketch, so I can be pretty confident that this is the geometry that I want. If you do have diameter here and you want to change this, you can toggle between radius and diameter pretty easily in the leader options for any of the dimensions. I would suggest putting your dimensions in the same style as they're given in the drawing. That's going to make it a lot easier for us to just kind of make sure that we're doing everything correctly. You have to worry about math errors or whatever. All right, so let's revolve that. So I'm going to go to revolve boss base. I have 2 center lines on here, so I have to pick which one I want to use as my axis of revolution. So I want to use the central axis, the one that goes through the origin horizontally in my sketch. And I do want this to be 360 blind, so it's fine going all the way around. If it's 360, then it doesn't really matter what the direction is. That looks pretty good. I want to mirror this. So I did this in the right plane. And so the plane that's going through the half of it is kind of the front. So I'm going to click on that and the revolve. I'm going to use control to select multiple objects and then use mirror. Again, it's going to mirror about the front plane with entities revolve 1. If you hit mirror first, then you just have to make sure you make these selections. And again, don't forget you can select out of the model tree here as well. Now we've got the initial geometry here. And I want to check and see, does this match one of the multiple choice options that I'm given? Just as a way of practicing for CSWA, we do have most of the CSWA questions start with this multiple choice, and that's there to allow you to confirm that you've got kind of the majority of the geometry correct. If you're off even by a little bit from one of these, you're going to want to check and make sure you're correct, because you're more likely to be off on the subsequent kind of enter in response or enter in value questions if your multiple choice one does not match exactly one of the options given. So I have 13816.27, 13816.27. So we're good on there. I can go on to the next part. Again, if you don't get the exact value, just go through and double check all your dimensions, make sure everything's fully defined, and then you can proceed. All right, this next section here, it wants us to use the part from the previous question and modify it to include the tread groove shown below. This one does not have any global variables, so it didn't give me an A, B, C, D kind of thing, so I don't have to worry about that. So all the other dimensions should stay the same. In this case, I've got 4 grooves. Each of them is 30 degrees apart. And we're going to assume that this is symmetric about the front plane, or what I've defined as the front plane, just like it was in the previous question. And yes, let's go ahead and do that. I don't want to have to do this 4 times. So I'm actually going to use this using 2 circles, and then I'll add it to my mirror. So I'm going to scroll back using the rollback bar to hide my mirror, because I want these 2 circles that I'm going to do to exist before my mirror exists. I'm going to go to the right plane again, which is the plane I sketched on initially. I'm going to sketch on that plane. And then I want to put 2 circles on the perimeter of this wheel. So I'm going to use a center point circle, click on the perimeter of the wheel, click to give it a diameter, click on the perimeter of the wheel, click to give it a diameter. We've actually been given this as radius. So I'll go to smart dimension. I'm going to add the dimension for that. I'll give it a value of 10, just because I know that's twice the radius, but I am going to go into here and change this to an R5. So that way it matches the radius that I'm given. So I'll accept that. I'm going to click on both the circles, holding control, and make them equal. The advantage here is that if I want to change this R5 later to something else, I only have to change it once. I don't have to change it in multiple places, which saves me some time. And then I want to have a center line that I can use to define the angles. So I'm going to do a center line from the center of my part here. I want the center of this arc, so I'm going to hold my mouse over the arc for just a second. And then I see I get the snap for that. So I'll come down and click on that, come back up to the center of my other arc. And now I've got 2 lines that I can use for dimensions. So this is symmetric, and I know that the top ones are going to be 30 degrees apart. I'm actually just going to use a little bit of math here. So I'll define this as 30 divided by 2, which if you trust yourself, you can just say, yeah, 15, that's correct. Do the same thing with this one. I'm going to say that this is 30 degrees. And now I'm still underdefined, but I think I have the things that I need for this. So I'm just going to move this around and see what I'm missing. I probably have a relation on here that I thought I got, but I didn't. So you can see I thought I got the center of that circle, but it didn't actually keep it. So it's still missing that. Instead, it got the coincident on this vertical line. If I click on that, you can see those 2 relations. So I'm just going to try and add a concentric relation between the arc on the outside perimeter of my tire and my center that I'm using for these lines, and make those concentric. And there we go. Now we're fully defined. So again, if you ever have a situation where you're underdefined and you think you have everything you need, just try to move some stuff around and see what happens. And then, if you know that obviously this isn't right, I need something that keeps this position vertically defined, and all I have is the fact that it goes to the center point of this arc, well, then I need to have the center of that, that pattern, if you will, to be on the center of my arc. So hopefully that makes sense. Now, there's 2 options here for the axis of revolution, because I want to cut revolve these circles to make the groove along the perimeter of the wheel, which means that the axis that it needs to revolve around is actually the center of my tire. Since I made the origin at the center of the tire, the easiest thing to do is just to use a center line that goes across the origin, right? And I want to keep that horizontal because that's going to be the same line that I used when I did my initial revolve for my first part. And so if I actually go into my initial sketch here, you can see I have that center line in there. If you didn't make the origin of the part, the center of your revolve, like say you made the origin up here because you drew this geometry first, You can still do this revolve. You just got to make sure you select the same line as you used in your sketch. And I can actually do that outside of the sketch option. So I'm going to exit the sketch for the run that I have here. So up here, I've exited that sketch. And I'm going to go into features, and I'm going to do revolve cut. And you can see when I select the sketch that I drew, it's going to want to use this center line as my axis of revolution. And because I have that, that's great. But if I didn't have that line, I can still go into my other sketch here and show that sketch, and then click on the initial line that I used in my first revolve. So if you don't have something that makes these two lines kind of at the same reference point, you can always pull in the initial reference from your previous sketch, and that works just fine. Another thing you can do, just to further complicate this, is that I can use the cylindrical face on the inside of this tire to generate an axis. So I can go into reference geometry, axis, and that's going to make a line at the center of that cylinder, which is also going to be the center of the wheel as well. So any of those three options works fine. With that, I'm going to re-show my mirror. I'm going to edit this to include my cut for the treads. And now I've got the treads done for this second revision on this part. And again, we'll go to evaluate mass properties. I'm going to copy the mass of this from my mass properties menu, make sure that I'm using the right unit. So it wants mass of the part in grams. I've got mass of the part in grams. Just always good to kind of double check you're getting what you want to get. And then you can go on to the next part. This slash section here is a little bit tricky because it wants us to make a groove in the tread on the perimeter of the wheel, but in the transverse direction. This is tricky because it requires us to kind of remember what the diameter of this arc was, or at least know to look for the diameter of this arc. And again, if I want to, I can even show this sketch again, so that way I have this arc that I can manipulate as part of my features. Although we don't have to do that, and most of the time, if we can, we prefer to use things that are a little bit easier to work with. So I'm just going to go to the top plane. I could also use the right plane for this, but I'm going to use the top in this case because in my sketch, I can see that I have a groove that is going to lie on the top plane, and I don't have one that's on the kind of the right plane here at the top or the bottom. So I'm going to go to my top plane, and I'm going to sketch on that plane. Actually, no, sorry. Let's do this a different way first. I'm going to do the front plane. I'm going to sketch on the front plane, and we'll see how this works in just a second. So I want to make a groove that goes across the circular kind of face of the cross section of this. What I'm going to do is I'm going to draw a circle, and I'm going to put that circle on the perimeter of the wheel. And be very careful if you're doing something like this. I have two lines that are very close together. You see that this one here is the line on the top of the tread. This one here is the actual perimeter of the wheel. So be very careful that you're getting the perimeter of the wheel. And I can bias my mouse a little bit on the outside to be sure that I'm getting that correct value. I can place that in. I'm going to set the size of the circle for the groove to 10 millimeters. And again, I'll change that to a radius just so it matches what I'm given. And then the radius of curvature, right, the arc distance, or the kind of the distance of the path that I want to use for this is going to be equal to the radius of the curvature of that outer tire. So I'm just going to set this equal to 54.5. And that might be a good reason to use a global variable in the sketch, even though we're not given it as an ABC value. We can use that to specify that distance. I also want to make sure that I have this circle horizontal across because I need this line to have a perpendicular distance of 54.5. So this is a horizontal distance. I want to make sure I keep my arc center horizontal from the origin. So I'm going to click on the origin of the part. I'm going to click on the center of my circle, make those horizontal. And now you can see that fully defines the position of that arc and the position of my center line. So that's good. I'm going to do revolve cut. And we can see that that revolve cut is going along the kind of perimeter of the outside diameter of that tire. I don't want it to go the whole way around, so I'm going to change this to a midplane. And I know that this is 330, so 330s is 90. And that should give me the parameter that I like. And again, I can make sure this looks right by comparing the detail view here with what I have on my screen to make sure that looks correct. And then I want to pattern this out. Before I pattern this out, I'm going to show you one other way of doing this. So I'm going to go to the right plane. I'm going to sketch on the right plane. I can convert this very edge of my wheel. And then I can drag this out to make the path of the groove. Make sure the endpoints of the path are concentric with the groove on either side of the tire. So there's a fully defined path. And then I can use that path, do a swept cut of a constant circular profile with a diameter of 10 millimeters. And that's going to give me the same geometry as I had using the revolve cut. Either of those works fine. I kind of like the cleanness of having all of these just revolves. But either of those will give you the same geometry. So, either one you can use for your, if you have this question on an exam. I need to pattern this. So again, I'm going to use my circular pattern tool. And if I have that central axis, I can use that. If I don't, I can always use the axis from one of my sketches or just the cylindrical face on the middle of this part to specify the axis of revolution for this pattern. I want 30 of these, so I'm just going to type them in. I don't want to have to click up the up button that many times. And we do want to have equal spacing. Unless they say specifically that it's something else, you're definitely going to want to use equal spacing on most of these kinds of patterns. And I can accept that. And now we've got a new part. Again, we can evaluate mass properties. This question wants to know the mass of the part in grams. So I'll copy this over, paste it into the prompt, and it should be good to go. All right, that's it for this video. I can make another one on the second half of this, which is the assembly practice. If you guys want, let me know and have a good day.